Robodog lanes are open for business. No humans allowed. So here is the challenge. Students must create a robot, either stationary or movement, just like regular bowling. They have a little bit of a runway heading down. Black line is the foul line, and so therefore they cannot cross that. Otherwise, it's a scratch, just as in bowling. And they must work all the way down, trying to earn a strike. And so we have created these walls here. So it is bumper bowling. So they can projectile, they can roll, they can launch, they can kick. Anything is game as long as the robot doesn't cross the black line. They'll be given 3 frames. See who can score the closest to 30 points or 3 perfect strikes. That is the challenge for the day. Pumped, ready to go, excited to see what the kids will create. Here we go, Robodogs Robotic Camp, day 3. What'd you say you're gonna add?
It's like ramp, and so it rolls down it and shoots out.
Okay, and why'd you decide to add that?
Because it wasn't getting enough speed by just us putting it right there.
You figure if you can gain some momentum dropping it, it's going to be enough? And how is the ball going to shoot?
Because he's spinning.
Is it just going to drop or what?
It's going to shoot out and then roll across the ground.
Okay.
Kind of talk me through what's supposed to happen
So
here.
we place the ball here, and then these are supposed to go shoot it out.
Should we try that with a different ball?
It's in a good spot. Okay.
Basically, you're going to squirt it out of there, huh?
Yeah.
Create enough power?
Like that.
Oh!
If we tried this,
I'm not sure you need
Through what you're currently building here.
Okay, so I was thinking that like weave ball, it's gonna start back here, but I'm gonna have things up here, like little V's of these that hold the ball so it doesn't fall out, and then it'll go like that, and these will hit something, which will knock them down, and the ball will roll out.
So the ball's going to release when your arm goes forward? Mm-hmm. And what are some of the things you think you're going to have to probably fine-tune?
Probably we need walls here, and we're probably going to have to fix the walls more than once because of the size of the ball.
Okay.
So, yeah.
What about this piece here? You think this is going to hold up?
No, so we're going to have to stabilize this, and we've already had to stabilize the motor, so it wouldn't fall.
Here we go. Go ahead.
So we were making kind of a ramp thing where we're gonna take this piece and attach it here somehow, and then fall on there.
and then
the ball's going to sit right here. We're going to release the gate, and it's going to ride down, and it's going to knock down the pins. And that's the basic idea of our design.
So what are some of your concerns that you have to overlook or kind of look at to hope that?
Well, one of the things is how we're gonna get the ramp to like sit up here because this is kind of heavy. So we're just gonna have to figure that out, and then that's it.
And another concern is we're going to have to build walls so that the ball doesn't ride off the side.
Okay.
And we have to figure out how to do that.
And what angle are you shooting for? Do you think is the optimal angle of your ramp?
We haven't really.
45.
Maybe somewhere like this.
Are you going to make your design so you can adjust that?
Yeah,
We're going to have it so you can like slide it up
slide
and
it
down.
out.
So we're going to have it like this. The ball's going to be right here, and then this is going to, like, we're starting to
Basically
attach
making a
this.
ramp.
Yeah, and then we're going to use this. And then, so we're going to program it so then it goes like this. And then it'll go down the ramp and into the pins.
So what are some of the things you're a little worried about that you have to really focus on?
Well,
The accuracy of where the ball is traveling when it goes down the ramp. If it's gonna like go to the side or anything.
Well, how are you going to troubleshoot that?
Well, we're just basically gonna test it and see what happens, and then if it does go to the side, maybe we can fix it by making it wider.
So it's going to shoot it forward as fast as possible. So we can try and knock down all the pins.
So what do you think are some of the challenges with this that you're going to have to make sure you get just right?
We have to have the amount of power has to be just right.
Okay.
Because we don't want it to be too fast, otherwise it'll just miss.
So what do you think you're going to have to adjust to get the power just right? How are you going to do that?
We're going to have to test it a lot and with different levels of power so that we can see what perfect is, I guess.
yeah, we should make sure we have the right speed. Otherwise, if it goes too slow, it's not going to hit much pins. If it goes too fast, it could miss some pins.
So the ball's got to be the perfect. This distance between here has got to be perfect, right?
Yeah.
So how are you going to make sure that's done? You're just going to.
We're just going to
Measure, I guess.
put a measure, yeah.
So
Just going to
Alright.
put them together. Or stick the ball through.
From yesterday, me and Graham thought to draw up a design, and our design was going to be like to have the brain be dragged by like these pieces, and then have this tire have it shoot forward, and then the color sensor stop it, and then it'll shoot forward, go through this tire, put it really fast down the track, and we're looking for as much speed as possible to knock down all the pins.
What are some of the things you think you're going to have to really make sure that are just right in order to make it work? That you're really concerned about?
What I'm concerned about is the brain on the back, because if that gets off, it's going to pull out all the cords and it's going to make everything just stop in its tracks. So this is the main thing I'm worried about right now.
What I'm worried about is if this ends up like getting loose and it just makes the ball just stick in there, we'll have to redesign the tire part of it. And we might not get as much speed on it if we lose this.
So how does the drawing help you kind of see this?
If we had two different ideas, he'd be building something and I'd be building something, and they would just not fit together. So the drawing helps us know that we want to have something here or something here or something here.
And pretty much what we're doing all together.
All right. Good luck, guys.
So what we're doing over there is we're just testing it to see if the medium or the large is more powerful. And so this one, it seems is faster, and when we tested it, we just set it on the ground, and it sort of like threw it, and then we did it so it went the other way.
So how are you going to use that test to
So it's kind of
implement?
like that, and then we set it on the ground, and it just hit it. Hit it. That
We're going to make it like
kind of like
it's going to rest on the ground and then it's going to flip and launch the ball.
Okay. So what are some things you're going to have to pay attention to with this design that you're a little bit nervous about?
Well, we kind of have to make it so the motor only does like half rotation. Because if it does a whole rotation, it's just gonna.
So we were thinking that we could connect, we could have the ball sitting here, and then this would like throw it overhand and knock down something.
You're going to have an overhand throw.
Yeah.
All right. So why do you have so many motors? What are you thinking there? Extra power?
Yeah.
So it's going to be a stationary, and you're just going to basically throw it like an overhand pitch. Okay. All right. Good. Make sure you get tested it. What kind of ball are you going to go with?
We're going to test both of them, but I think it'll probably not support the cue ball as much, so we'll go for it.
All right. Good idea.
Well, this thingy's gonna turn something on it that's carrying like the ball, and it's gonna flip down, and it's gonna go all down these staircase thingies, and it's hopefully gonna hit down all the pins.
Okay. So that thing is going to release it? I'm confused on that.
Yeah, this thing's gonna, so there's gonna be something on it. It's not necessarily gonna be this. It's gonna be something on it. It's just gonna turn, it's holding the ball. It's gonna turn, and it's gonna flip it down all these skids.
So what are some of the concerns that you're worried about that you don't have figured out yet that you have to test and check?
Well, this is gonna go all the way around, all the way to the other side. Not long enough. And it's not long enough, so we gotta find a longer one.
So it's going to be stationary. Would you figure out what ball, or are you not sure what ball you're going with?
We're gonna go for the heavier one.
Okay. All right, good luck.
Well, we decided maybe we want to put one of these, so we're going to take a lot of those. And we're going to have a launcher, and press a button, and it launches the ball, and the ball rolls down super fast, goes between those. That gives it a little extra push, and then it'll roll down, and then it should hit the pins down pretty well because it's going at a very high speed.
So that's going to guide it into your throwers, huh? And what do you think are some of the things you're going to have to pay attention to as you start designing that you're worried about that might be some issues?
Well, the ball might be a little heavy and might break the things, or it might tip over.
Anything else, Vicky?
It could like go off the sides, so we have to put like something on the edges to make it not go.
How can you remedy that?
Maybe use like balloons like in somewhere else.
As you can see here, we have two motors over here, and then connected to those motors are these gears, which spins these gears here. It spins this little gear here, which also spins this big gear. And so then it just kind of, what it'll do is it'll let this wheel spin a lot more faster than it would normally spin if it was just connected to the motor. Because by having that on both sides, we hope that we would be able to just put the ball in and it would shoot out.
Okay, but you can't put the ball in by hand. How are you going to get the ball started in there?
We're thinking on building a ramp, so then we'll put the ball and it'll slide down in between the two wheels, and then shoot out and knock down the pins.
Very good. What do you think are some of the things you're going to have to pay attention to that you're a little worried about not working right? What are you worried about?
The gears mainly, just because if the gears get off track, then it's not going to work at all. And so we just need to watch out for those.
All right, good.
We drop the ball here, and then these are turning until we hit the stop sensor or touch sensor, and then it'll go off like a regular tennis shoe.
You guys got this built pretty quick. Is it doing what you thought it'd do?
Yeah, we tested it several times.
So what are some of your concerns in the testing that you need to improve on, you think?
One of them is why we kind of fixed it, but I'm still not sure about it, is where it only worked if one tire was going and the other side wasn't going. It kind of got fixed, but now we need to angle it.
Which ball are you using?
The pool ball.
It looks like a very workable tool. You just got to get it honed in, right? All right.
What we're gonna do is we're gonna attach this right here, and then we're gonna connect something right here that
We're gonna
look
use
like this.
We're gonna use gears to double the power to go over the maximum of 100 in the programming.
So then once we have the gears, we'll have something sticking out of this gear right here that will go all the way across to connect to another one of these sets of gears. And in the middle will be a giant swinging arm. And what it will do, this is what the swinging arm will look like. And
It
it'll
will
hit,
propel the
it'll hit a ball. It'll hit a ball into the bowling pins. And we're trying to get the most amount of power as we can, so it makes it and hits more than one pin down.
Definitely a workable idea. What are some of your concerns that you're worried about that you're a little nervous?
On.
and the accuracy.
Because you're like hitting it with a hammer kind of thing, huh?
Yeah.
How do you make it roll, hit it exactly the same every time? All right, I can't wait to hear though.
Alright, so we have a program downloaded onto here. What we're hoping it will do is get enough force so we can launch this ball into the bowling pins.
So it's going to come over the top?
Yeah, and hopefully hit the ones in the middle. And we have these right here for protection. Because if you didn't have these, the ball would just like roll off the side.
You be the
Coach Terry.
Yeah.
Yep.